Here we're going to work backwards. We're given a graph and we need to work backwards to find your equation. Now, technically you might be asked to find a sine or a cosine. We're only going to be focusing our attention on finding the cosine. The A, the B, and the D are the same between the two. Since sine and cosine are really the same function but just slid sideways, a different phase shift, your C value for your sine function is going to be different than your C value for your cosine function. But we'll be just looking at finding your cosine um, function. So to find your A value, it's max minus min divided by 2. You can see looking at your graph, we top out at 5 and we bottom out at -2. So if we plug our max and our min in, then we can find our A value and we get 3.5. D is your max plus your min divided by 2. While we were just dealing with your max and your min, so then we can go ahead and plug them in and we get our D value to be 1.5. As you look at your graph, you can see that your period would go from the top point here to the top point here. This is a 1/6 of a pi to the left. This is a pi to the right. That's a total of 1 1/6 pi, or it would then be a period of 7 pi over 6. So if that's your period, you go your peanut butter equals your normal period. P times B is equal to your normal period of 2 pi. We solve it for B, and we end up getting this. So we plug in our A value, we plug in our B value, we plug in our D value. C is when the maximum occurs. The maximum occurs at -pi/6. So we're going to put x minus -pi/6. Now you'll notice C, or we have more than one max, so C could have been over here at pi also. So another equation, you could have had your A, your B, and your D being the same, and then you could have had an x minus a pi. So go ahead and find your cosine function. You're told a situation where you have your temperature at midnight, and then you know what's going on with your temperature at midnight, and you know it normally cools off at night, so your temperature goes down, and then the sun comes up and your temperature starts to rise. We know we bottom out at 10 degrees. We know we max out at 20 degrees. So it's very similar to our last problem. We go our maximum, which is 20, our minimum, which is 10, max minus min divided by 2 to find our A value. We have our max and our min. We can go max plus min divided by 2 to find our D value. Our period in the context of our problem is 24 hours because our temperature for the most part repeats every day. So our period is 24 hours because we're dealing with hours up here. Peanut butter period times B is equal to 2 pi, so we plug in our B value being 24. We solve it for our B value and we get pi over 12. So we put in our A, put in our A value, put in our B value, and plug in our D value. Once again, when you're dealing with cosine, and it's only when you're dealing with cosine that C is when your max occurs. In this case, maximum occurs at 18 hours. So that means C is 18, so we can go ahead and plug in 18. Now, whether you have your function drawn out or your function given to you in data, it's really the same thing. So here we have the depth of the river at different stages given to us in feet, time versus this. Now, the reason our river goes up and down is because the river is emptying into the ocean and the ocean has tides, so that affects the river right as it dumps into the ocean. So we need to go ahead and find our maximum. So you can look through your data, you can find maximum here. Actually, there's a second maximum over here because you should, if you've ever been to the ocean, you should realize that there's two high tides and two low tides every day. So we have our maximum, and then we can see our minimum, the lowest point, is at 18. So we can find our A value, max minus min, divided by 2. And then our max plus our min divided by 2 for our D value. Now, your tide is not occurring for your high tide or your low tide at the exact same time every day. It's affected by the moon, and the moon's not in the exact same spot every day in the sky. It changes some. So what we're going to do to figure out our period here is look at our maximum at 3 in the morning. Our next maximum is at 4 in the afternoon. Well, 3 in the morning to 4 in the afternoon is 13 hours. So that's our period. And we can use our peanut butter period times b is equal to our normal period of 2 pi. 13 times b is equal to 2 pi, and we get our b value. So we plug in our a value, we plug in our b value, we plug in our d value. Now here, our c value is still when the max occurs. Our maximum is occurring at 3 in the morning. 3 in the morning is 3 hours after midnight, so C is 3.